Hey guys, this is Note Video 5.3 on how to draw ionic bonds. This is going to be a little bit shorter one compared to the next one dealing with covalent bonds. A little bit less work you've got to do to draw the ionic versus the covalent. So we're going to jump right in, be on page 11 in your note packet. Basically, what we're thinking about is building on what we've already done a little bit, those Lewis dot diagrams. So ask yourselves, what are Lewis dot diagrams and kind of what do they show? Think about that for a couple of seconds. Remember, they show us the valence electrons that an element has. Excuse me. So think back in the last unit, we're kind of continuing to build on those valence electrons. Those are the important ones. They're the ones that are bonding for us. It's not really those inner shells, it's just the outer ones. So with ionic compounds, basically it's just going to give us a picture of the compound, kind of what it looks like, and it shows us the arrangement of the atoms in the compound, where they are, how they're interacting with each other. Within ionic, remember, as I said I would do, you've got to remember it's a transfer of electrons, okay? That transfer that's taking place, and it goes from the metal to the non-metal. So that's what we're going to have to show with our pictures, that there is a transfer taking place. So I said these are a little bit easier to show than the covalent. The covalent's got a whole other piece kind of going into it, so enjoy these ones while they last, because they're going to be a little bit easier and simpler and quicker than the covalent ones. So there's going to be a step process that you've got to follow. If you skip steps, that's where things will go wrong. So the first thing is just draw the elements, kind of show their individual Lewis dot diagrams. So we're going to kind of do it on this document, kind of going, one here, 2, and then 3. You guys will kind of do it left to right when you get your practice problems, and I'll show you that a little bit as we get to one of those. So the first thing, draw your two elements. Draw their Lewis dot diagrams. So sodium, if you look up, it's in group on your periodic table. It's got 1 valence electron because it's in group 1. Chlorine, you probably already know by now, has 7 valence electrons. So remember with your Lewis dot diagrams, and really one thing you'll see a lot, you don't necessarily have to, the regions probably won't mark off, but one could be represented with dots, one could be represented with X's, so that when they come together, you can actually see where the one came from. Okay? But remember, neutral atoms. We're starting with neutral atoms here. We don't have ions until they've actually bonded, because remember, an ion either gains or loses electrons. Right now they're neutral in their neutral state, so do not put any charges there. It's just the number of valence electrons, which you can find from your periodic table. Step 2, we're going to draw the electrons going from the metal to the non-metal. Your goal is to match up all the unpaired electrons. There should be none left unpaired when you are finished with your structure. Excuse me. So what we will do is we will actually draw an arrow, put a circle around the metal valence electrons, and we're going to draw an arrow showing that transfer taking place. Okay, so I kind of drew it up there. I really should just redraw it down here. When you guys get into practice, you'll have it in just one spot, so you won't have to redraw them every time, but for notes it's good to get in the habit of drawing these out. So circle around my electron that sodium's going to give, and it's going to go to that unpaired electron in chlorine. All right, so now we're going to redraw our final structure, and this time dots in appropriate new charges because they formed. So sodium has given its electron away. Think back, what type of ion forms when you lose an electron or you give it away? It's going to be a cation. So when we draw cations, brackets around your element, will a cation have any dots? No, because it gave it away, but it will have a charge. So sodium lost one, so you can either put a plus or a +1. They mean the same thing. Chlorine, on the other hand, is gaining that electron, so it's going to have all of its dots, all of its full valence electrons. Now I draw the X there just to kind of show you now that, hey, that X is showing that it came from another location, it came from another atom. You don't always have to do that. You'll see me do it early on, but then we'll kind of drop that as we go along. And then it's also going to have its charge because it gained that one electron. Remember, you have to have charges. Oops. Have to have charges with ions. Okay, if they don't have a charge, it's not an ion, and it's going to be wrong because if without that charge, it's telling the person grading it that, hey, this is just a neutral atom. So that number is wrong in terms of valence electrons being 8 or 0 if it's neutral. That's why it's important to have the charge. So I want you guys to go through, pause the video now. I want you guys to try your best at showing this. This is what I was saying. You'll draw the separate ones here in this column, and then you'll draw the final product over here. So pause the video, and then check and see how you're supposed to do it. So I hope that you just paused it. I'm going to kind of work through these examples so that you guys are good and kind of understand the process here. And it is a process. It's going to take time. You've got to do the practice. So here we go. Potassium, it's got 1 valence electron plus a fluorine atom, which has got 7 valence electrons. Okay. So it's an ionic bond. I've got a metal and a nonmetal, so I know it's ionic. It's going to go over here and transfer that in. It's going to give it to fluorine. Fluorine's readily going to accept it. So now our final product here, we'd have potassium with a plus because it lost its electron. Fluorine is going to have all 8 valence electrons now. I'm going to put an X there, still early, and then a negative sign. So that's what your final product should be for the bonding that takes place between potassium and fluorine. Next one. Barium has got 2 valence electrons, a little bit different. Sulfur has 6. Now remember, spread them all out first before you go doubling up. I know I just drew them like that. Really, you should draw 1 in each of the 4 spots, then go back and double up before, so that we have those unpaired. So now, 1 barium is going to transfer in here to that unpaired. The other barium is going to transfer here to that unpaired electron. So now we should see something like this. Barium still is going to have none because it was the metal. It lost its 2 electrons. But now it's a 2+ because it lost 2 electrons instead of 1. Sulfur gained those 2 electrons. So we're going to show sulfur's 6 that it had. And I'm going to draw X's showing, hey, they came from somewhere else. They came from the barium. And it's going to have its 2- charge. Okay. Now, this last one, if we draw it out, aluminum is a metal. It's got 3 valence electrons. Now, yours might look like this, right? Because I showed you guys, hey, the top 2 fill in first, and then the other ones kind of run around. I don't really care as long as you have 3. The regents won't care as long as you show 3 as well. Now, bromine, notice we have a 3 here. Shouldn't really surprise you guys too much. We know that in compounds we can have multiple atoms, and that means we have 3 bromines. If you just kind of isolate it and do one at a time, okay, I've got bromine that has 7 valence electrons. So it only needs 1. So if I just have 1 aluminum here, okay, and I kind of transfer this there, well, bromine's happy, but is aluminum happy? No, because aluminum still would have 2 valence electrons here, so it's not stable yet. That's why we need to have those 3 bromines, because we would need 2 more to kind of take up the other 2 electrons that aluminum wants to get rid of so that it's stable. Okay, so if you come across a problem where it says, oh, these 2 elements are bonding together, and you notice that you need to bring in more than 1, you can do that as long as with as many as you need to balance it out. So this guy would come here, okay, and then our final structure would look something like this. Aluminum, brackets. Anytime you have an ion, has to have brackets. And we're going to have 3 bromines, all with brackets around them. And all the bromines are going to have 8 dots. Now I realize that my space is limited here, so I'm going to draw bromine over here. The third one. Negative charge. Mine are getting sloppy here. That's okay. As long as I have the 8 dots all around it and the charges. Okay, so that's what they should look like. Now, if they give you the formula, it makes it easy, but if they don't, they just say, hey, aluminum plus bromine. Okay, it's kind of up to you to figure out how many you would need. So by drawing it out, okay, and kind of going, oh, this is what they would normally be, and I say, oh, look, well, aluminum isn't enough. You could then, like I said, just add the other two if they didn't already give you the formula. Okay, so big thing to take from this, draw them out originally first. Ionic bonds are transferring those electrons, so we draw an arrow to represent that. And then the final piece means that they have to have their appropriate charges that are new. They didn't have the charges before. And put brackets around them to show that, hey, there's that transfer that's taking place. Remember, cations are going to have no dots around them. Anions should have a full octet. So now you guys can go through and practice this practice sheet right here on your own. And when you get ready and you think you have it, call me over and I will grade it for you.